Hey guys, Dr. Brown from Kubo Math coming to you from Tarlac City, Philippines. And today we have a 5th grade problem that we tried to work today in 1 minute and 11 seconds, but we couldn't make it. So I told the student, I said, okay, I'll work that tonight and we'll throw it out on a video and you guys can see how we did this. So here we go. All right, they've got a number of strawberries in a box, and the number is somewhere between 40 and 100. So that's how many strawberries are in a box. We don't know exact, but it's between 40 and 100. But when the worker puts them in packets of 2s, he has 1 left over. When he puts them in packets of 3s, he has 1 left over. When he puts them in packets of 4, he has 1 left over. Whoa. But when he puts them in packets of 5, he has none left over. How many strawberries are in the box? Well, the way you can approach this, or at least this is how I approached it, was if he puts it in packets of 5, there's no remainder. So we know the number is divisible by 5. And it's between 40 and 100. So we'll say if it's between 40 and 100, they're not included. So he has 45, 50. These would be the possibilities. 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, and 95. Those would be the possibilities. Okay? Now then, if it's divisible by 2 without a remainder, that means it's an even number. It has to be an odd number to have a remainder. For example, if 3 divided by 2, okay, 1 times 2 is 2, 3 minus 2 gives me a remainder of 1. But if this is an even number, 4 divided by 2, 2 times 2 is 4, 4 minus 4 is 0. There is no remainder. So if I look up here and I have an even number, that's not a possibility. So let's get rid of any even number. 50 is an even number, 60 is an even number, 70 is an even number, 80 is an even number, 90 is an even number. Whoa. Okay. That took care of all the possibilities associated with a 2. Now then, what about 3s? We've been studying if you can take the digits and sum them up and it equals some number that's divisible by 3, then that is in fact a number that can be divided by 3 with no remainder. So if that's the case, for example, 5 plus 4 is 9. 9 divided by 3 is, 3, so you can divide it. So let's just challenge that. 45 divided by 3. Okay, 1 times 3 is 3. 4 minus 3 is 1. Bring down the 5. Oh, wow, 5 times 3 is 15. No remainder. Okay, so now we can look down through here. If I have any of these numbers that add up to be a number such that it's, or any of the digits that sum up to be a number that's divisible by 3, I can get rid of it. So 45 goes away. That's 10, that's 11, that's 12. Oh, divisible by 3. That one can go away. 8 plus 5, 13. 9 plus 5, 14. Okay, so these are my 4 possibilities left. Now then, what about 4? Now you know the rule for 4. You're looking at the last 2 digits of the number. If you can divide 4 into it, then it's divisible by 4. Well, I only have 2 digits. Okay. But in our case, we want a remainder of 1. Well, 55 divided by 4. 1 times 4 is 4. 5 minus 4 is 1. 15, 3. So now I'm going to have a remainder of 3. Well, I need a number such that I have a remainder of 1. That won't work. Okay? All right, so 55 is gone. 65. Now you could go about this in a little bit of a different way, I think. We could have said, what's the least common multiple of a 2, 3, and a 4? Okay, well, 2 divided by 2 is 1. Bring down the 3. 4 divided by 2 is 2. I'll go with 2 again. Bring down the 1 and 3. That becomes a 1. Do a 3. Bring down the 1. 3 divided by 3 is 1. 1. Bring over the 1. So 2 times 2 is 4. Times 3 is 12. 12 times 1 is 12. So least common multiple is 12. 12, 24, 36, 48, 60, 72, 84. That's promising, isn't it? 96. Now we're past that. So in my mind, these two numbers right here would be the ones that are in interest, because the least common multiple of 2, 3, and 4 is within 1 digit of those numbers. So that's the ones I'm going to focus on. For example, 65. I know 5 goes into that, obviously. That's the only numbers we have left. But if I'd put a 4 in here, 1 times 4 is 4, 6 minus 4 is 2, 25. 6 times 4 is 24. Well, that's leaves me a 1, right? Okay, 65. What about 3? Or 65 divided by 3. Well, 2 times 3 is 6. Whoa, got a problem here. 2 times 3 is 6. Bring down to 5. 1 times 3 is 3. That leaves me 2. Remainder of 2. That one's out. 65 is gone. Okay? So that's why my 84 and 96 are of question. 95, let's see, what about divide it by 4? 2 times 4 is 8. 9 minus 8 is 1. Bring down the 5. 3 times 4 is 12. I've got a remainder of 3. No good. So 95 is out. So what does that leave me here, Mr. 85? Or as 96 was out. Okay, so 85. I'm sorry, it wasn't 96, is 95. So because multiples of 5. So 85. Well, 85, we know if we divide it by 2, it's going to be a remainder of 1. It has to be. It's an odd number, but we'll play along anyway. All right, 4 times 2 is 8. 8 minus 8 is 0. Bring down to 5. 2 times 2 is 4. Remainder of 1. 85 divided by 3. 2 times 3 is 6. That leaves me a 2. Bring down the 5. 8 times 3 is 24. Remainder of 1. Hey, 85. 4. This is going to work out, isn't it? 2 times 4 is 8. 8 minus 8 is 0. Bring down the 5. 1 times 4 is 4. 5 minus 4 is 1. And 85 obviously is divisible by 5 because it ends with either a 0 or 5. Ends with 5, so that works out. So how many strawberries are in the box? There's 85 strawberries in the box. Cool 5th grade problem. All right, why are we doing this? Hey, we're trying to build a better tomorrow and do that through math. Obviously, we're doing that together. Together, we're trying to build a better tomorrow through math. Study, 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 okay? You guys are doing good. Just keep doing good. Keep the pressure on yourself. Good pressure, happy pressure, learning, growing your mind, okay? All right, that's all for now, and we'll talk to you next time. Thanks.